Welcome to Chip Logic Studio, and today's our topic is synchronous versus asynchronous in digital design. So in this video we will focus more about Verilog coding and not about the concept. We will understood the concept as per our coding. So watch full video, and this is very important question. So let's start with our synchronous. So what do you understand by synchronous? Synchronous means when a thing or a clock, for example, oscillator, clock, any signal which will synchronize your other circuit, it is called synchronous circuit. Means at that trigger only the other signals will work. That is called the synchronous thing. Now, all state changes happen with respect to clock edge, passage or negate. This line is respect to our Verilog coding. Whenever there is passage or negate with the respect to clock, then only our other signals will work. For example, if you have created registers, counters, FSMs with the help of Verilog coding, then that signals inside that registers, counters or FSM will work with the respect with clock. Either it may be passage of clock or either negate of clock. So we will say active edge of clock. That synchronization is called synchronous. So more predictable and easier to verify. The synchronous signals are easy to verify because we will only see whenever there is clock edge and data is changing or not. So it is more predictable. Predictable means whenever there is clock, we can predict that data will change, and easier to verify because at the same time we can verify it. Now reset enable signals are sampled only on the clock edge. Means every signal is synchronized. Every control signal is synchronized with a single clock. All data are coming, all control signals are coming. This is what synchronous is. Now let's take this example. So here our clock edge is here. Let's assume it is here, which is a passage. Our reset is synchronous, so it will work with our clock. For example, this is active edge of clock, so our synchronous signal is 1, for example, and it goes down. Okay, so it is working with our active edge of clock. Whenever the active edge is clock, then it is 1, then it is 0. And our similar for our data also. Let's assume that data before the active edge of clock is X, unknown. At the active edge clock, reset says it is 0, because at reset we will say our data is 0. Then when reset is not there, means reset is active low, then we will say whatever data is there, we can send it that data. Again reset came, then again data will be 0. So what is the process here? Whenever there is clock, active edge, all reset and data is synchronous with this clock. Means whenever the trigger is there, then only the data is there, or reset is there. Everything is synchronized here. So this is what synchronization is. Now we will see one code for that. Here is the code. Synchronous reset means at every passage of clock, it will check whether the reset is there or not. Then only it will decide that either output is 0 or either output is D, means any data. So whole thing is synchronized with our clock. This is our synchronization. Synchronous clock, synchronous reset. Now what is asynchronous? Opposite of synchronous means there may be some signal which is independently working without the synchronization of clock. Means the signal which is not dependent on the clock, that signals are our asynchronous signals. For example, reset in flop or set in flop. Whenever there is reset, the clock output is 0, so it is asynchronous, which is not related to our clock, and useful for bringing system into known state at power up. For example, if chip has any failsafe, so failsafe system should be asynchronous now, because if it is synchronous with the clock, then chip will not work properly. Whenever there is a problem, it should directly go to power down. That signal should be asynchronous, and it is trickier to verify because we don't know when it will come. Because if failsafe is there, then it is unpredictable, then something might have happened. That's why it is trickier to verify asynchronous signal. Potential glitches and metastability is not carefully synchronized, because that signal is asynchronous, so we cannot predict it. If there is a metastable state or there is a glitches in that signal, we cannot see. Now let's understand this concept with the help of a graph. Now assume this is our clock at passage of clock and our data is there. Now reset can come any place. It will not depend on our clock, but data is our synchronous signal. So reset is not our synchronous signal and our clock will synchronize with our data. So data is X. Now here active edge of clock, there is our reset in middle, and now we have to follow reset because it is a synchronous signal until next edge of clock it is 0. Again the reset is there, then also we will say it is 0. Now it is 1, then also it will be 0 until next edge. Now it will say that signal our reset is actually low, then we will see that data can be there, it will be 1. Now this is our asynchronous signal reset. Whenever it is coming, we have to follow it. Now for example in clock, here in our code, our clock is our passage of clock and our reset is also passage of clock, which we seen previously. Whenever there is 1, then only we are doing our data 0. I have explained that example with our D flop example. Now asynchronous, we have used here counter code. So whenever the count is 0 at passage of reset, and it will be independent of this clock, and count is incremented with the help of our synchronization with the clock. So here both the things are working together. One signal is synchronized with clock and reset is asynchronous. It is coming independently and doing our signal to reset to 0. So this is, we used our synchronous and asynchronous concepts in our Verilog coding, and this is a very good example of counter and D flop which you can use in your interview. So 1 or 2 year experience engineers can have this question in any interview. So thank you for watching this video, and whatever concept you need, you can comment it.
I do, so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patent